In August of 2018, the students of the California Academy of Mathematics and Science were introduced to Project Azorian. This mission in their Advanced Engineering Design and Development class would bring on the trials and tribulations that one would find in a real-world engineering setting. With a new mission being assigned every year, this would undoubtedly be the most challenging yet, but if accomplished, would yield the CARPA Initiative's most impressive student-made product to date. Prior to being introduced to the mission, the students assigned to the class were given a flash challenge. The parameters: create a product within given size constraints that would be capable of launching a raw egg as far as possible without it breaking. With no sense of direction, they were set free to go about the challenge as they pleased. What was the purpose of this challenge? The class that launched their egg the farthest with no damage done would win the advantages of a small grant to kickstart their project, picking who would go first for the first critical design review, and arguably, more importantly, they would get first choice of their team color. During this time, students also had the option to drop the class if they were not ready to commit to the year-long mission, leaving only those who were ready to take on whatever was thrown at them. After a series of designs and tests, the day came for the two classes to face off. Using their trebuchet model, the class that would soon become Echo Technologies proved their capabilities by surpassing the other class who would soon become Umizora Technologies. From there, Echo selected blue as their team color and opted to go second for their first critical design review. Soon after, official positions were established to provide structure and more accurately imitate a real-world engineering setting.
Hello, my name is Adrian Massas and I'm Echo Technology's Quality Assurance Officer. I mainly chose this role because of my familiarity and experience creating technical drawings, and my roles within Echo Technology include component inspection and the inspection of the technical data package for both the interns and the members of Echo Technology.
Finally, after the period where students were allowed to leave the class was over, they were introduced to Project Azorian. CAM's Advanced Research Projects Agency, CARPA Initiative, has tasked Echo Technologies to design and build a UAV UUV vehicle named Megalodon that can recover items of interest from the K-129 crash site after pinpointing a signal from a UUV vehicle named Remora that locates those items of interest and recovers radioactive items. This mission is an attempt to recover the leftover parts from a nuclear-capable K-129 crash that the CIA failed to completely recover from the ocean floor. As the ship was raising the K-129 from the ocean floor, it broke apart and part of the submarine was lost. The mission will begin with the Megalodon picking up and placing the Remora into the water to locate the crash site. Once the crash site is located, Remora will recover the radioactive items after inspecting the crash site with a UV light, then rise to the surface to signal for the Megalodon. The Megalodon will then transition to underwater and swim to the crash site to recover the remainder of the K-129. The Megalodon will deposit the parts it collects before coming back to retrieve Remora and travel back to land.
Right now, we are currently breaking down the mission for any constraints as well as criteria and any obstacles that we might face during the mission or throughout the year. And we will then think of solutions and different approaches to how we can overcome those obstacles.
With a mission so complex, the students needed to begin working if they were to be able to create a product capable of movement in the air and underwater within the 8-month timeline. However, the senior class was not the only ones with their hands on the project. Echo would also host a team of underclassmen interns who would take on the role of producing the Remora, responsible for locating and collecting radioactive materials underwater. Like in a real-world engineering setting, Echo would interview and select their interns from a pool of applicants.
So I was part of the internship program last year, and I felt that the senior team didn't really help us at the beginning as much as they did at the end, and I just felt that if they would have been there since the beginning, we would have been able to complete the project. So as the director of interns, I wanted to ensure that the interns had the support and guidance that they needed to complete the project in a timely manner. I hope that they enjoyed it and that they were able to learn something about themselves, whether that's how they work in a team or whether or not they actually like engineering. I feel that the internship program does a really good job of showing the pressures that there is when you're a senior in the class. So, anything that goes from TDP to the design to building the actual robot. I do expect them to complete the mission, but more than that, I want to see personal growth within them. They tend to set very high expectations of themselves, and then they get a little disappointed when things don't turn out the way they planned. But at the end of the day, they realize that they can get it done. So I hope that at the end of this year, they can realize that they can do anything that they set their minds to.
With their first CDR, Systems Performance Specifications, approaching, ECHO had established their corporate identity, selected interns who would also be presenting their idea for Remora, and prepared a 149-page document that would pair with the presentation showing their design for the Megalodon. With an audience of industry professionals from engineering firms like Northrop Grumman and Motivo being in attendance, it was important that the class was prepared and professional.
So SPS is the Systems Performance Specifications presentation. At SPS, what we do is that we pretty much break down all of the concepts of our design and as well as explain any of the plans that we have in order to manufacture and actually build our Megalodon.
We are going with a quadcopter design for aerial, meaning 4 aerial motors. For underwater, we have 6 motors, 4 positioned vertically, and then 2 for horizontal or yaw control. So we've made a last-minute design change leading up to SPS. That was to go with 4 vertically facing motors for underwater instead of the 2. And the reason behind that was to have more stability and controllability. And it's really made this last week more intense in terms of workload. But I think it'll be worth it. We have a much better design that's really accounting for an issue we might have in the future. So that's all good. And then to recover the objects of interest off the bottom of the pool, we have sort of a dustpan approach where we ram the objects and then have a spinning servo that will push them into our dustpan. And then that's the purpose of that is to try to make it easier on the programmers. We'll see how that works in testing. And then in addition, just for redundancy, we have a ballast system in case the underwater motors aren't enough to hold our altitude. We have a ballast system as well.
After a more than successful SPS, the team was given useful feedback from the industry professionals and set off to further develop their product and make appropriate adjustments. During the time between then and the next critical design review, proof of concept, the team went in full speed on working on the robot and in other aspects of ECHO. Aside from being able to grow technical skills, EDD also gives students the opportunity to take on more administrative roles. FOM, standing for Finance Outreach Media, are the 3 sub-teams that focus more on community involvement, finances, and developing the company's corporate identity.
Finance team raises money to enable all of their departments to complete their parts of the mission. We've received contributions from CAM's administration, Motivo, and many generous individuals, and many more.
Coming to CAMS and seeing that many students hold great potential to innovate and design things without having the proper guidance in the past has inspired me to go out to the community and be the helping hand that pushes younger students who may have doubt in the skills to show their innate talents. Personally, I have a passion for outreach because I have been in that position. Entering high school with the desire to pursue in STEM but not being as educated on the topic in comparison to others has lowered my confidence in my capabilities. And although not having background knowledge on STEM is not a bad thing, I want to reassure others that had the same mindset as I did. And so, because I did not have the chance to learn it, I pursued this position in order to give others that opportunity. My favorite outreach event was the first event held at the Boys and Girls Club in Wilmington on Valentine's Day because of how engaged the students were within the STEM-based activities.
With proof of concept approaching, the team had further developed their Megalodon prototype, bringing together components from various sub-teams including electrical, manufacturing, and programming. This was their time to test the various aspects of Megalodon, including flight and vision, in front of industry professionals. Beginning with a flight demonstration, they showed their Megalodon would have no issue with flying the required 201.9 feet. Following that, they showed how they were able to translate radio frequencies over distance by producing a sound. Then, the interns team, Ripple Technologies, exhibited their prototype's working claw mechanism to be used to retrieve radioactive materials. Finally, the programming team flexed by displaying the Megalodon's vision tracking system.
Although programming has been mostly hands-off of the robot most of the year, I believe programming is the department with the highest ceiling for innovation. Throughout the year, we've done everything from designing a multi-layered control loop for flight. We've done communication between multiple processors, and we've created a completely new algorithm for underwater autonomous object retrieval. A specific example of our work was shown at POC, where we demonstrated full 3D pose estimation of a vision target in 3D space. We were able to use the corners of the vision target to calculate the object's complete orientation and position, and we were able to use this information for our autonomous algorithm. Programming is all about acquiring as much data and information as you can and synthesizing it to reach your goals.
With another successful critical design review and even more feedback, the team was left to prepare for their last test, Mission Day, where they would finally be graded on how much of the mission they were able to accomplish. Leading up to Mission Day, it was detrimental that the team have a mission strategy to most efficiently complete the mission. For that, we turned to the team strategist.
So from the beginning of the year, when the mission was first introduced to us, we wanted to make sure that the strategy was something that was being continuously developed. The general idea was to make sure that the plan was the best plan with the highest efficiency so that our robot could perform at its best. Now, while the mission was changing and while our design was changing, that meant the strategy had to change as well, so it was definitely an iterative process. So we had to change the strategy as long as our design's capabilities matched that plan. So for the final mission, it was based on the levels of difficulty of the tasks. What that meant was that we would do the things that we knew we could do, the things that we deemed were easy based on our design, and then move on to more difficult parts. So when we were recovering items, a dual pilot view was used.
Finally came Mission Day. On a Saturday morning at Cabrillo High School pool, it was time for the culmination of 4 months of work to be shown off. Echo Technologies more than surpassed the expectations by not only being able to accomplish flight, but also being able to retrieve all items of interest from the K-129 crash site. With the completion of the mission came a sense of accomplishment. A team of high school students managed to come together on a strict timeline to produce something truly incredible. And with that, Echo Technologies proved that we had ideas worth hearing.